Hello and welcome to the Aadi Labware Rat and Mice NIBP Monitoring System deep dive video into the considerations and precautions one is to take while conducting this experiment. In the previous videos, we have covered the different parts of this instrument and the installation procedure also. Here, before we jump into the considerations and precautions part, I would shortly touch up upon the different parts of this instrument. The first, of course, is the power cable. The second is the high fidelity instrumentation power supply. The third is the heart of the system, the data acquisition and control system. Next, we have the bioamplifier and the data collimator. Next is the animal restrainers, which as you can see in the video, we have shown two kinds, but they come in a total of 5 or 6 different sizes depending upon the weight of the animal. When a researcher or an institute procures this system based on the nature and the weight of the animals in their laboratories, we are able to guide them on the correct choice of restrainers. Next, of course, we have tail cuffs, again in multiple sizes depending on the size of the animal. Next, we have the PID controlled rodent warming chamber, a very important part of this instrument because if the ambient temperature in the laboratory is below 31 degrees, then we ideally put the animal in this warming chamber to increase the blood perfusion in the tail and to ensure that the vasodilation is sufficient enough to cause an easy identification of the different parameters of the NIBP test. Next, what we will do is we will briefly see how the experiment is conducted before we start studying what considerations and precautions a researcher needs to take to make sure the experiment is conducted successfully. First, of course, we choose a suitable sized restrainer and put the animal into the restrainer. The restrainer must be sized so that the animal is snugly held into the holder and not it should not try to escape it, because it will try to escape it eventually. It should not be able to turn back or something. It should be very comfortable inside the restrainer. We need to now warm the animal. We take our warmer and place the animal for somewhere like 5 to 10 minutes into the warmer. The temperature setting in the warmer at our factory site is done 32 to 35 degrees. But of course, this is changeable if the researcher feels they need to change it. But the factory settings set it at around 32 to 35 degrees. Between in this range, the temperature would be maintained inside the restrainer. And very important, the temperature probe needs to be placed near the tail of the animal, so that because that is the area where we are primarily concerned about what the temperature is in that region. Now we start the experiment with the cuff on the tail. We see some pulses on our desktop lab monitor software. As the pressure rises, some physiological change happens, but of course the pulses vanish, and we keep an eye on when the pulses would reappear. That is what we are looking for, when the pulses reappear. In a moment, here they are. So we can see that the pulsations have reappeared into the tail as the occlusion is removed in the deflation cycle. And you can see that there is a rise in the amplitude of the pulses as the pressure goes down. Right. So the experiment is completed. And now we have the different parameters of the NIBP experiment given to us by the software, we can see that the BPM, the beats per minute or the heart rate of the animal, came at 318, which is standard for rats. The systolic pressure, the SAP, systolic arterial pressure, came at 113 mm of Hg. The MAP, the mean arterial pressure for this rat, came at 90.48. The DAP, diastolic arterial pressure, for this rat came at 79.22. The software, of course, allows us to put some fundamental information about the animal also, like animal ID, the type of the animal, the species, that is, whether it is Vistar or something else, the sex or the gender of the animal, male or female, the weight of the animal, of course, very important. And then, of course, the adjacent accept button we can click and transfer all these details into the database where they stay forever. Unless they are deleted intentionally, they would not go anywhere. And then you can do a long-term longitudinal study by taking multiple readings on the same animal. And it is as simple as that. Of course, the software allows us to take data out into PDF, which is non-editable paper trail, and also in MS Excel, which allows us to do some permutations and combinations if in future we are required to do that. And now we are prepared to look into the different considerations and precautions that are needed to be taken while conducting this experiment. We have divided the considerations and precautions into three parts: the pre-test part, during test part, and lastly the post-test part. In the pre-test, the first thing which needs to be taken attention of is to select an appropriately sized restrainer and cuff to ensure stable positioning while minimizing unnecessary stress or movement artifacts. As we have already mentioned this, an animal will always try to escape its restrainer. So the restrainer size should be such that the animal is snugly held into the restrainer and it is not trying to escape it, because if it tries to escape, it will give you motion artifacts. And also, if it is too tight for the animal will feel anxious or stressed inside the restrainer, and it will have body jitters, which will come into its tail also. And that jittering tail will give you some motion spikes on the sensor. And the sensor for a rodent NIBP is specifically designed to be extremely sensitive, because of course the blood perfusion in the tail is very low. It is very low, and to be able to pick signals on that low perfusion tissue, the sensor needs to be extremely sensitive. Now, when the sensor is so sensitive, it will pick a lot of things which are not signal. Even jitters, body jitters, and motion artifacts, it will easily pick them. Now, a instrument does not know what is signal and what is noise. It is impossible to know that. Unlike human eyes, which can see the graph very clearly, okay, this could not have been signal, this was absolutely noise, because we notice patterns very easily. That is the human evolutionary benefit. But the instrument itself will not know that. So if suppose at 200 mm Hg of pressure, when the pressure is going down during the deflation phase, it sees a spike which is actually caused by either a jitter or a motion artifact, and it sees a spike, it will think, oh, that's the stall, that is the SAP. But that is not actually the SAP, that is actually just a motion artifact. So, just to avoid all these things, we have to make sure that the animal is not anxious. It is very comfortable but very snug inside its restrainer. You can see on the bottom left corner, we have about 8 different sizes of restrainers, and depending on weight, one can choose what size of restrainer one needs. And tail cuffs also, they come in three sizes. Animals should be habituated to the restrainer for approximately 3 to 4 days prior to experimentation. Recommended habituation frequency is 3 to 5 sessions per day, each lasting approximately 2 to 5 minutes. This is very essential. Uh, the first time you're doing the experiment is not the first time the animal enters its restrainer, because it will panic. It will think, what is happening to me? So, before you conduct the experiment, 3 to 4 days before that, start getting the animal used to its restrainer. For no particular reason, just put it into the restrainer for a couple of minutes, take it out, do this 3 or 4 times a day, and that should be sufficient for the animal to know that it is not being harmed, it is just a restrainer. That is very important. If the ambient temperature is below 30 degrees Celsius, pre-warm the animal for a minimum of 5 minutes using the warming chamber to promote adequate tail vasodilation and improve signal quality. Ambient temperatures vary a lot depending on your geographical position, your laboratory conditions, they vary a lot. Very important if you're in a hot or warm climate and you have air conditioners in your laboratories, it is best to switch it off while the experiment is being conducted. We do not want a cold environment around the animal. And in any case, warming is advised because warming improves the blood perfusion in the tail and the vasodilation, and that helps capture the signals best. For ensure the animal is in a calm physiological state prior to measurement. Avoid loud noise, abrupt movements, rushed handling, or excessive restraint, as stress can significantly alter cardiovascular parameters and compromise data reliability. That is also obvious because not only will you probably get some motion artifacts, but also the physiology itself changes. If an animal is stressed, its BP goes up, its heart rate goes up, and we do not want those factors to be recorded in our research. What we want is purely the cause which we are trying to study to be recorded. We do not want to add causes to the change in its cardiovascular parameters. Verify proper cuff and sensor positioning before initiating a measurement. We have already touched upon this. One thing we have not touched upon is, ideally, the cuff, the tail cuff, should be placed on the basal tail region because the blood perfusion is best there. In our sensors, we are able to get some signatures out of even the middle region of the tail, but literature does not advise that. Literature advises that for best results, we reach the basal tail region. Ensure the tail is clean and dry prior to sensor placement. When using animals in a laboratory, anyone who has been with animals will understand that animals, being living creatures, they leave droppings, they leave urine on the platform. The the warming chamber can be contaminated. The restrainer will get contaminated eventually. So one needs to make sure that the tail region where the sensor is placed is generally clean, and animals generally manage that. Somehow they themselves are clean, everything around them they manage to soil, but themselves they manage to somehow remain clean, and we want to make sure that they are clean while we place the sensor on the tail, because that unless it is clean, you can have some problem in the signal integrity. Minimize environmental disturbances, including vibrations, excessive airflow, and certain acoustic stimuli. We have already mentioned this because that will eventually make the animal anxious, and we do not want that. We want the animal in a very calm and relaxed state while the experiment is conducted. Allow the animal sufficient time to stabilize after transfer to the experimental environment before beginning measurements. Very well understood, very obvious. For longitudinal studies, maintain consistent experimental conditions, including operator, ambient temperature, warming duration, and time of measurement. Rodents are nocturnal animals, and cardiovascular parameters may vary significantly between light and dark cycle phases. Experimental timing should therefore be standardized across study groups wherever possible. And this is obvious. Every parameter which goes into the experiment needs to be standardized, whether it is the operator who handles the animal, whether this is the ambient temperature around the animal, fix that, whether it is the warming duration, 5 minutes or 10 minutes or 2 minutes or 3 minutes, make sure that that is standardized, whether this is the time of measurement, at what time of the day you're doing this, because we mentioned that rodents are very sensitive to time of the day, even significantly more sensitive than humans are. They're nocturnals and they're able to pick light cycles, dark cycles. So we mean everything which goes into it needs to be standardized. We now move to the considerations and precautions during the test. Now, during the test, ensure the animal remains calm and exhibits minimal movement during acquisition. Coming to it again, excessive motion may introduce artifacts, compromise signal quality. We already talked about this. Observe the live pulse waveform and oscillations amplitude throughout the measurement cycle. Unstable or irregular signals may indicate poor perfusion, improper positioning, or motion artifacts. It is very essential that we observe continuously the graph which is coming on the screen. That will help guide us whether the signal was good quality, bad quality, had motion artifacts, did not have motion artifacts. That is where we visualize how good the experiment is. Avoid touching or disturbing the restrainer, sensor assembly, or tubing during the measurement. Very important. Anything we touch gets vibration. Now, how we do this is when we put the animal into the restrainer and we thread the tail, the sensor through the tail, we hold the tubing like thus, such that if the tail is here and the sensor is here, it is not touching to our own tissue. Because as I will mention this again, it is a very sensitive, very sensitive sensor. And if it is in contact with human tissue, you will get some noise. So we do not want that to happen. So just like this, hold the restrainer with your hand, very steady, very stable, and the tubing will be guided through the V section of your palm. And just like that, you hold the restrainer with the tail underneath your palm. Ensure the tail cuff and sensor remain properly aligned throughout the acquisition cycle. Very important. A change in alignment will cause you some motion artifacts. If pulse amplitudes remain weak or inconsistent, allow additional warming time to improve peripheral vasodilation. Very clear. Do not perform measurements immediately after handling, transport, or other stress inducing procedures. We do not want a stressed animal inside the experimenting area. Avoid conducting measurements in environments with excessive vibration, airflow, or sudden acoustic disturbances. Already we have touched upon this a couple of times. If repeated acquisition failures occur, reassess the animal positioning, cuff placement, sensor alignment, and physiological state before continuing. For optimal reproducibility, maintain consistent measurement conditions across all the animals within a study. Very important for reproducibility. If you have multiple animals, 6 animals, 8 animals, you need to maintain the same conditions on every animal, and that is operator, ambient temperature, time of the day, warming duration, warming temperature. Everything needs to remain consistent for all the animals. Review waveform quality before accepting recorded values. Very important, and we've mentioned this once previously. We need to make sure that the waveform is clean before we accept it and record the values. Now moving to the post-test considerations and precautions. Number one is allow the animal time to recover fully before returning it to its cage or proceeding with additional experimental procedures. We do not want to do too many repeated measurements on the same animal, so we let it relax a little. Inspect the tail for any signs of excessive cuff pressure, impaired circulation, or irritation following repeated measurements. very essential. A clinical observation of the animal is good. Clean the restrainer, warming chamber, and sensor contact surfaces according to recommended cleaning procedures before subsequent use. Very important point. We want the area to remain clean and hygienic for the next test. Restrainer we understand, warming chamber also we understand. Sensor, when we talk about cleaning the sensor, we have to be very careful about this. Sensor is not to be cleaned in the same way a restrainer or a warming chamber would be cleaned. When we talk about cleaning the sensor, what we mean is that inside is a diaphragm, a specially designed diaphragm, which is a consumable part of the sensor. All we do is we remove that diaphragm and discard it. We use a fresh cutting of the diaphragm. We do not use the same diaphragm, but a sensor assembly is under no conditions to be cleaned using IP or soap water or anything like that. Anything like that would eventually damage it. Avoid performing excessive repeated measurements in rapid succession, as repeated, restrained, and cuff inflation and occlusion can and will potentially affect the tail vasculature and local physiology, especially in small rodents. And that brings us to the end of the considerations and precautions deep dive video. If you feel that any points have been left out or something more could be added, do please feel free to contact us on www.aadilabware.com. The link or the address is in the descriptions. We have a contact page where you can reach us through a message and we will promptly get back to you. Or you can directly write to us at aadilabware, AADILABWARE at gmail.com. Thank you for staying with us. Have a good day.